Hello everyone. So continuing with our series, today we'll be solving a symmetric tree question. So you are given a root of a binary tree and you have to check whether it's a mirror of itself. So basically it should be symmetric around center. So let's look at this example here. So if you see here, let's say this is the central line or the mirror, you can see that this node is equidistant from the mirror and its value of these two nodes same. If we talk about this node, it's equidistant from the mirror and value same. Same is the case for this node, equidistant and the value same. So this is a symmetric, so output will be true here. Let's look at the another example. Here we have this will be a mirror. This is equal distance, so we can see these two node satisfy the symmetric problem, symmetric condition. But if we see this condition, they are not equal distance from the mirror, so it will be output will be false. So that's the question. I hope you understood the question. Uh, let's go to the solution. So let's first talk about the idea behind the solution. Okay, so the idea behind solution is so suppose this is the mirror. So whenever you do a certain iteration, uh, so basically you'll be reaching some node at the left side of the mirror as well as the right side of the mirror. Okay, so you have to satisfy two conditions: equal distance from the mirror. Okay, and second condition is value should be equal. Value of node should be same. Okay, so these are the two conditions that needs to be satisfied here. So to identify whether this tree is symmetric or not, you have to make sure that each of the subtree are symmetric. So if this symmetric condition breaks at any point within the subtree, then all the above tree will not be symmetric. So suppose let's say you do some iteration, you reach, so you do iteration at the left side of the mirror, and you do the iteration at the right side of the mirror. So what you do is, let's say for iteration you move away from this mirror. So in the right side part, you have to move away from the mirror as well, because then only it will be equidistant. If you are moving toward the mirror, then you have to move toward the mirror as well in the iteration. So with respect to this node, if you are moving left side, so you have to move the right side here. Okay, or if you are moving right side, then you have to move left side of this particular node. Okay, so let's say you make a iteration and you reached a certain node. Okay, so whenever you let's say move toward the right side, then you're moving toward the right side, you'll be reaching a node. So moving toward left side and right side, or moving left side and then right side, will make sure that this condition satisfy equal distance from mirror. So let's say after making an iteration, you move at a certain point or certain node. Now you have to check the second condition, that the value of node should be same. So let's say if you move left side here, move right side here, you reached two nodes. Now you have to check the value. If the value is same, you go further down the subtree. And if any point of the time, if this value does not satisfy either, you are not able to move equal distance from the mirror. So this can be the case where you have a something like this, one, let's say two, let's say three, and let's say you have this four here, and but it does not have any node. So you are able to move toward the right of the mirror, or toward the mirror, but here since there is no node, so you are not able to move. So this condition won't be satisfied here. So uh, uh, as soon as you see this condition, you return false, because that won't be symmetric. Or let's say the value is not equal, let's say 1 2 and something like this, 3 here. you are able to move equal distance but the value is not same, so this will not satisfy this condition. So in that case as well you will be returning false here. Okay. So that's the idea behind the solution. Now let's look at the code part. So what we have to do is we have to start from this root node. You're given input as a symmetric function and a tree node, and you have to return whether it's a symmetric or not. So what you have to do is in each iteration you will be going one level down. Okay. So let's say you go to this level. Okay. Now this level has a two nodes. Okay. Now you go to this level. Let's say this level has four nodes. So at each point of time or each iteration within a level, you will be only be considered about two nodes. You won't be considered or you won't be taking into consideration other nodes in the level. So at each point you will be taking, let's say, these two nodes, then in the same level in the next iteration you will be taking these nodes, right? And you are going level by level downward. So in such a condition or such a scenarios where you have to go level by level, and in each level you are specifically considering a certain set of inputs or the values. In such a case it's always better to use recursion here. So we'll be using recursion here. Okay. So if we see the code, uh, I'll calling this isometric util, or I'll passing this root left basically. So distance away from mirror and the root right here. So distance away from mirror. So this will be this root left and this will be root right. So I have got two root node here. So if both the values are null, so something like this. Okay, so it's a symmetric, so we'll return true. If either of them is null, so if let's say something like this, because we now are not able to move here at this uh, node, because there is a no path here, so we'll return false. Okay, now once we reach at this point, that means we are able to make a movement, we are able to move equal distance from the tree here. Okay. So once we reach this point, we are basically getting reached at 2. So here we have to check the second condition. If the values are equal and this subtree of this left, okay, and this subtree of this right are symmetric, okay, then we can say that this whole tree is symmetric. So whenever we call this symmetric util root 1 left, root 2 root right, it will again search for this subtree. So let's say assume it would have been some further nodes here. So it will check there. So recursively it will check all the subtrees, and whenever we see that this condition is correct, we return true here. If any point this condition is not correct, we return false here, and this false is going to get propagated till the top, and finally it will return false here. Okay. So if we see the example, let's say we see this example here. So first it will go here, okay, and it will go here. Now it will come here, it will see. Now we call this function. And we'll see that this particular node and this particular node both are null, so it will return from there. So here it will return true. So from left side, this part will return true here. Okay. Now we see this part. This will come here and this will come here. Sorry, this will come here. So if you see this, there is a node at. So basically, you can make a movement uh, toward the mirror, but here there is a no node, so you cannot make a movement. Okay, so this condition will return false here. Okay, so here it you will get a false. So this will be false. You will return false here. So this false is going to come here. Okay, again it will get false here. It will return false here. Okay. So finally you will get false as output. So I hope you understood the question uh, as well as the solution. Do let me know if you want me to solve any other particular question. That's all from my side. Bye bye. Take care.